Good morning, everyone. You're listening to the Sci-Files, an exposure segment featuring Michigan State University student research. We're your co-hosts, Chelsie
and Daniel Puentes.
A little bit about Sci-Files is that we are both graduate students, and we want to interview graduate students as well over here at Michigan State University. The point of this is so that everyone around Lansing and East Lansing can understand what's going on at MSU. A lot of people don't have much of a connection to MSU, and we were hoping that we could help reach our audience and everyone else out there so that people can feel connected to us.
As Chelsie mentioned, the goal is to help the community feel much more engaged with the scientists that are resident here in both Lansing and East Lansing. So we thought that this would be a wonderful idea to help the community feel connected to us.
Without further ado, I would like to welcome Jennifer Watts.
Hi, guys.
Hi, Jen.
So, Jen, why don't you tell us a little bit about yourself and what you're doing here at Michigan State University?
Awesome. Well, I want to thank you guys for having me, first of all. I'm really excited. So what brought me to MSU?
Yeah.
So I did a summer research opportunities program here at MSU in 2015. I fell in love with the campus. I really liked the research that was going on here. So it was important for me to apply here. Once I applied here, I got accepted. I knew where I wanted to go.
Great. And what are you doing now in regards to your research?
Yeah, so I'm a PhD candidate. I just finished my comprehensive exam in the fall. Thank you. At MSU, I work in Dr. Amy Ralston's lab, where I understand the effects of Zika virus infection in early development. So Zika virus has been in a news cycle as of lately, and really we want to understand the connection between why this virus is causing these effects in babies. So yeah, that's my research.
Okay, and I would definitely agree that has some very immediate societal impacts to what we're facing today in today's day and age.
Yeah, both Danny and I are from Miami, so I remember whenever this outbreak occurred that a lot of people were worried about getting bitten by mosquitoes and things like that, because I recall that they were saying that pregnant women should be very wary about that. Could you explain what it would do to these pregnant women if they were to get bitten by a mosquito with Zika?
Yeah, so that's very interesting because we are actually in our lab looking at a different aspect. Yes, the Zika virus can be transmitted through a mosquito, but it can also be sexually transmitted. And that's why we have this paradigm where the Zika virus can infect really early, potentially after conception. So really the focus is on pregnant women. And the mosquito biting the women, it transmits to the fetus and then causes those issues such as neurological defects or malformation of the head, which is called microcephaly. But in early pregnancy, we think it could be more damaging and cause miscarriage.
Okay, so wow, it's worse to catch the virus in the early stages of a pregnancy than it is in the later stages.
Yeah,
that's really interesting.
That's what we're really trying to find out, and whether it's time dependent or not.
So I'm assuming that you guys infect different fetuses or embryos or something like that with Zika and see how it affects the development after that?
Yes, so we use a mouse model to understand that. So what we do, we use this cool technology that we can grow fetuses in a dish, and we can add virus to it. That way, so we don't have transmission of the Zika virus from mouse to mouse.
Oh, wow, yeah, because that's an interesting point that you're bringing up right there, because one thing that I could understand being difficult is preventing the transmission of Zika through sexual intercourse rather than artificially putting it into the dish.
Exactly. And another thing that I kind of want to add to this is that the Zika virus, what we know is that it can reside in male and female reproductive tracts. So it can pretty much infect sperm, and it can infect female eggs, mature eggs. So with that knowledge now that we have, is that we can potentially have like an additive effect of the Zika virus once fertilization occurs. And so that's why we really want to figure out what's happening in a dish, just because we don't want to get too complex, because we really can't pinpoint what's actually happening in sexual transmission that's causing these effects in fetuses.
One question that I'm curious about now, let's take a quick step back and think a little bit larger. Does Zika work a lot like other viruses where once you have Zika, it stays in your system forever, or does it eventually leave your system?
Yeah, so what is known is that it eventually leaves our system. So according to the CDC, what is suggested is that you wait about 2 to 3 months before you try to conceive if you have Zika virus detected in your body.
So how does your body get rid of the Zika virus? Can you use that way to help the embryos or fetus when they're developing as well?
I think that's a really interesting point, and we actually don't know. One thing that we could suspect is that our blood regenerates, so it's flushing out and filtering out those virus-infected blood cells. That's one hypothesis that we have, but we really don't know, and that's something that some researchers should find out.
So the fetus is not strong enough to actually get past it, and is that baby born with Zika?
I'm actually not sure. It can go either way. Like I said, I don't think that has been studied, so I'm not sure about that answer.
Well, maybe one of our listeners can figure out that issue.
Maybe, yeah, definitely.
So I was also wondering, you were talking about putting the Zika virus in the embryo. Have you put it in the sperm versus the egg and seen the difference of which one was infected?
So that is actually part of my research plan. We want to infect sperm, we want to infect eggs, and then we want to infect both to see what happens and see if development occurs normally or if we still have those issues with the fetuses after they grow up.
Wow.
Are you guys looking at ways to help fix that after? Like, if, let's say, that was better one versus the other, are you trying to see, like, how you can maybe fix it with vitamins or something like that?
Yes. So the last part of my project is to really understand how Zika virus enters the system, because that hasn't really been understood yet. So what we're using is these pharmacological inhibitors, or just inhibitors that will stop the infection of Zika virus. So one has already been shown to do that in other cells with Zika virus. However, we don't know how really that works in fetuses. So that is actually part of my research, and hopefully we'll get some good results from that.
So what I'm curious now about is, what role do you think Zika virus will play in the future? Do you think we'll come closer to ridding of this disease, or do you think there's a possibility of mutation? I wonder how Zika might be in the next 20 years by.
Yeah, that's really hard to say. But what we know from history, we have to go back to kind of look forward. What we know in history is that there's different strains where they originated from. I think the Zika virus was first discovered in 1947 in Uganda. So it's been discovered for a while now. So what we can do, since we know that it's mosquito-borne and is sexually transmitted, we can actually do some intervention before someone gets infected. So wearing repellent, staying away from climates that are conducive to mosquito reproduction. You can wear, we have nets and things like that. Also in sexual transmission, we can make sure that the virus is cleared from the body before we start to conceive again, so we don't have those issues. But hopefully, with my research, if we do still see virus in fetuses, those inhibitors that I talked about a little bit earlier, we can use that as a therapeutic.
So I'm kind of curious in the same line as Danny about the future of this. I was wondering, I haven't heard about Zika for years, like since I was an undergrad, and did it go away? Is it getting better because people can process it, or is it getting worse because it's still going around with the mosquitoes and whatnot?
So it hasn't been in a news cycle because I think we've kind of, at least in the United States, we have it contained. And also we have those preventative measures that we have. But I think it's still an issue. It's just not happening where where we are, right? So
yeah, we're Michigan.
Yeah, exactly. So we don't have necessarily those big mosquito problems, or the type of mosquitoes that carry this virus don't actually live here. So I think it's still a world issue, but it's just not happening in close proximity. So that's probably why we don't see it there. And there's some societal context to that as well.
Do you ever think that we'll reach the point that we have with malaria? The reason why I bring up malaria is because, for example, whenever America was involved with the Vietnam War, we would provide our soldiers and different GIs with pills to take to prevent malaria onset. What do you think the possibility of that is for the Zika virus in the future, and what are your thoughts on that?
Yeah, since it does primarily affect pregnant women, that may not be too big of an issue as far as making it necessarily global. It does affect specifically a population of people. But I think that once we find something kicking and once we find out if it does affect these fetuses in early stages, we can go ahead and make that awareness. We can really inform epidemiologists who really kind of get all this data together and inform the public that this is an issue. Once we find out those things, we can really make it a little bit bigger than people are making it right now.
It almost feels like for different regions of the world, you could end up eventually adding this as part of a woman's dietary additions for whenever they're actually pregnant, since pregnant women, from what I understand, would take special vitamins to help with the production of the fetus.
So my counter argument to that actually is that what if the woman doesn't know that she's pregnant? Then that's where Jen's research, I think, comes in handy, because then there's a treatment for that. Like, not everyone gets pregnant intentionally, so not everyone can even take their prenatal vitamins as they're supposed to, which affects the development early on. Yeah. And then later on, if they end up having the infection, what do you do then? You can't take the pill and just hope it works.
I kind of agree with both parts, right? We do have to take those preventative measures if you know that you want to conceive and all that. But on the other hand, we do have these instances where people get pregnant and don't know. And I'm actually studying those stages where the woman would not know that she is pregnant or not. So one thing to kind of talk about both points is that we can use these inhibitors both ways. All right, so we can use it as a preventative way, but after infection, at least we can reduce the effects that are happening to fetuses. So it's not really a lost cause there.
Wow, Jen, that's really great research. It's really important what you're doing for not only our community, but the global community as a whole.
Thank you.
Speaking of the global community as a whole, I remember that we were talking earlier before this about how you went to D.C. and you were talking to Michigan representatives about science and whatnot, which I think is very admirable, because it's a good idea to get the public to know about what's going on. Can you tell me a little bit more about that, please?
Awesome. Yeah, thank you. That was a really fun trip to D.C. So we met with multiple Michigan representatives, or at least their staffers, to talk about our research and also how different programs at MSU really does facilitate our professional development, whether it's either through outreach or just their community that they provide. So the program that I'm specifically talking about is AGAP, which is the Alliance of Graduate Education and Professoriate. So we talked to some staffers about our specific research, the broader impact like we just did. Also, we talked about what AGAP really provided for us and why we should still support these type of programs that includes everyone and also increases diversity in STEM and social sciences.
And how does AGAP do that?
So specifically for me, I think AGAP has really introduced this outreach part of me. Like I said before, I was in the SHROP program, which is the Summer Research Opportunities Program, and I was able to connect with graduate students here, got to see if they were happy, what type of research goes on around here, but also the professional development that they provided. They helped me write better, they helped me communicate better. Even after that, after 2015, I was able to win awards. I was on the news in San Antonio, which was my undergrad. Like all of that all together, those different tools that they gave me that summer, I was able to give back in 2017 when I was a graduate facilitator as well. And so it was really nice to talk to younger people and get them excited about STEM fields and also social sciences, whatever discipline they were in, and also talk to underrepresented students about how they feel about the current climate too.
So we talked a lot about professional things that you do outside the lab, but what about you, Jen? What do you like to do?
So I actually like to read. I also like to travel too. So recently I took a vacation to the Bahamas, which was really fun. DC was really fun to go to because we were able to go to a few museums while we were there. Like going to good old Texas, where I'm from, to see the different types of cultures that are around. So traveling, reading, just walking, seeing, sightseeing, everything like that.
Yeah, and 10 degrees, it's beautiful.
Yeah. Not right now.
And what would you say has been the most impactful novel that you've read within the last couple of years?
Impactful. I think this book always comes to me, The Brand New World. I think that's an amazing book by Huxley, if you do want to check it out. I read that like in either in middle school or high school, and that book kind of changed my whole worldview. And especially since that new story came out, making babies using CRISPR. Since that
twins.
came out, yes. Since that came out, I'm like, we're getting closer and closer to that. But I think that's the most impactful book. I think it really got me started in science. I wasn't fully committed yet, but I think that really put some science fire behind me. Yeah.
So did SHROP basically convince you to go to graduate school and to come to MSU and everything?
I think it started a little bit earlier than that. So I went to undergrad at the University of Texas at San Antonio, and I joined the RISE program, which is the Research Initiative for Scientific Enhancement. I started my freshman year, and I did a few labs there, and that really got me excited for my PhD first. And then I think what the SHROP did was kind of boost it up a little bit and also figure out what school I want to go to and do my graduate studies at.
Yeah, SHROP's a really important program here at Michigan State University. I'm actually an alum as well for SHROP.
Yeah, awesome.
It was an incredible experience.
Mm-hmm.
So you knew probably by the time you reached undergraduate that you wanted to pursue a degree in science. And what helped you develop this idea, and what was the final sign that showed that you are meant to go into this field?
Yeah, so it started in high school. My mother got really sick, and so she was diagnosed with breast cancer. And so for me, it was like going to the offices with her and like seeing what type of medicine she has to take and like, why is this making her sicker than it making her better? So I had that inquisitive mind in high school. And so that really catapulted me into going into sciences. And I actually did quite a bit of cancer research at MSU for the summer and at the University of Texas at San Antonio. So that's kind of my story into getting into the BS in science. And then from there, kind of just trickled down into going into more school. Mm-hmm.
Well, thanks for sharing that with us. So, What about you, Danny? What made you get into science?
I just knew that I always liked going to Kennedy Space Center all the time when I was a child. I just always thought that all of these different things were so interesting, and I always wanted to understand how they worked. So I wasn't sure exactly what I wanted to do. I explored different areas like marine biology and pre-medicine, but at the end of the day, what gets me going really is nuclear physics. Mm-hmm. What about you, Chelsie?
Well, growing up, my dad owned a computer shop, so I was soldering from the age of 3. I wasn't that great. I was burned a little bit. My mom wasn't happy about that.
Yeah.
But I always wanted to build things, and I loved going with him on jobs and seeing how everything worked, And I didn't want to do particular electrical engineering. I wanted a different option, and I loved how biomedical had so many different options. I did research in epilepsy, Alzheimer's, skin research, nano. I actually went to Texas A&M for a summer, and I did research on nanoparticles.
Nice.
And now I do research on the bladder. So I love that biomedical engineering is so different. I love that science can be anything that you want it to be. And I really hope that what we do right now with this show, that the community can see that scientists are real people, that we enjoy going out, we enjoy doing things, but we also want to express our research so that people can know what we're talking about.
Thanks a lot, Chelsie, for sharing that with us. So we're nearing the end of this interview. Thank you so much, Jen, for taking part of it. As parting words, what last advice would you give to different people in our community right now that have an interest in science but are not too sure about whether or not they want to pursue it in the future?
First advice is kind of just go for it. I mean, there's always times where you can stop and reevaluate, but also for people who are kind of going out into careers in science, the best advice that I got was that the job that you want is not made yet, and you have to make it. So I thought that was very, very powerful, and also that's going to stick with me forever.
Thank you so much.
Thank you so much, Jen, for your time.
Thank you to all of our listeners that joined us this week. And remember, the truth is in the science. Any comments and questions can be directed to Sci-Files at impact89fm.org. We'll see you all next week on Sci-Files.